Hi, and welcome to this tutorial video for nursing research. This is for week 5 of your class. Let's just jump right in. This is the week that you have literature review grids that are due for your final project here. So I have pulled up again the rubric. This should look familiar to you. It's the same that we've been using all along. This one was for week 4 and 5. Again, here for week 5, you have 3 research articles that you were to find from CINAHL or other library research web-based sites. You were to find 3 articles pertaining to your PICO question that you are trying to answer. And so again, for submission in Moodle, please print off the literature review grid that's posted there, and you can just expand that enough that you can put all 3 of your studies into one document and upload that. Of note, you need to do your APA citations. Please focus on not plagiarizing. If you are copying things directly from your research articles, make sure that you are citing those using quotation marks. Again, kind of doing in-text citations like you would in a paper, that you're giving credit as you're citing these things on your literature review grid. Each of the grids that you'll submit are worth 25 points. Each column is worth up to 5 points. So again, feel free to look. Here is kind of an example of one that you might be, you'll just want to kind of mimic what you're seeing here. So for week 5, your 3 literature review grids are due. Also for week 5, we will have a 3rd and final quiz for you to take. So let me share with you the study guide for this very last quiz here. There are no multiple choice questions, so hopefully that will help you feel a little bit better about this one. Again, I think this one is on the shorter side, so maybe only 10 questions that you're asking. You need to be well familiar with the importance of sample size as it relates to population. Be able to answer what is a prospective, retrospective, and case-controlled study. How do you define and use the term stratified random sampling? We went over that in last week's PowerPoint, so you could go back to that or read in your book. How do extraneous variables affect a study? The differences, again, between independent and dependent variables. We've been looking at that all along. Differences between experimental and non-experimental studies. Again, what are those level 2? And then the quasi-experimental level 3, and then our non-experimental studies level 4. Kind of what are the differences between those? And then here, you'll need to know differences between random clinical trials, correlational studies, developmental studies, cross-sectional studies, cohort studies, descriptive and longitudinal studies. So if I was you, I would just write out each of those terms and kind of create a definition of what those different things are. All right, hopefully that helps you out here. As we enter into week 5, we continue to kind of fall into the non-experimental studies section. We looked at cohort studies some last week, and this week we are going to look at case study a bit more in depth. We are also going to be covering information that was presented in your readings, chapters 15 and 16, where we look at concepts of reliability and validity as it relates to our articles that we're looking at. In quantitative research, we are measuring variables. The measurement of the variables must be reliable, meaning that we can measure them consistently, and valid, meaning that it's accurately measuring what we're looking for. Is it true? Will I get the same results each time I use this measuring tool? So we'll spend a little bit of time looking at chapter 15 on that. And also reviewing chapter 16, which is again kind of just an overview of statistics and how those apply when we're reading our research articles. So let me share with you here. Let's jump into our case-controlled studies PowerPoint for this week. As I say every week, of course, if you're having any questions or concerns with the class, do not hesitate to contact your professor. Let him or her know sticking points that you're running into, that sort of thing. We're here to help guide you through this, especially as you get towards the end of doing your projects here. So let's spend a little bit of time with case-controlled studies. Again, this would fall as a level 4 study, non-experimental, and let's review. So quantitative research designs, again, we have experimental and quasi-experimental, where the research provides an intervention and records our outcomes. We have descriptive designs where there is no control group. It just describes the phenomenon. This is often just to help us kind of, as we are early identifying a question, do exploratory research. And there is cohort studies. We talked about those last week, both descriptive and cohort, non-experimental designs. Cohort study identifies a group of people at risk for a disease. We measure their exposure and we follow them through to see who develops the disease. Again, each of these types of designs has advantages and disadvantages, cost, time, resources, and you have to really see what type of design is needed to kind of match what it is that you are hoping to be able to study. This is something that we went over again last week, but let's do it again. Do investigators assign exposure? Are they controlling things? If so, yes, we're going down that path of it being an experimental study again. Are they randomizing things? If so, again, we have that level 2 randomized control trial. If not, we're doing non-randomized control trials, or kind of quasi-experimental, right? Level 3. If the investigator is not manipulating variables, they are just observing things, again, we're over on this side where this is either an observational study, a comparison group. If we are comparing one group to the other, then we can say this is an analytical study, which could either be a cohort, case-controlled, or cross-sectional. If we're not really comparing one group to another, we're just saying this is a study, this is the outcomes that happened, then we're having a descriptive study. So again, if it's not experimental, if we're just observing things, we're not manipulating things, then we have one of 4 types: cohort, case-controlled, cross-sectional, or descriptive. So again, why do we need different designs? They help us in answering the specific questions. So for example 1, if you want to know how fresh vegetable intake is related to health throughout one's lifespan, you would start with this idea of exposure. In a second example, if you want to know what makes people more susceptible to hip fractures, you would start with the outcome being hip fractures. Cohort studies are good if we want to see what happens to people who participate in X kind of unknown behavior. Case-controlled studies are really good if we want to explore disease and what might have made somebody susceptible to it. And then trials are really good at looking at all this information and testing them, again, assuming that it's ethical to do the testing and reasonable to be able to do it. So what is a case-controlled study? In a nutshell, it identifies cases of people with some type of disease in place. It chooses controls, which are people who are similar to the cases, but they do not have the disease. And then it looks back into the past and it tries to identify what exposures, what lifestyle choices may have led to a certain group of people developing that disease and a similar group who do not have the disease. So it's really looking back to try and identify what might have caused that. So where cohorts move forward in time, case control is always looking back into the past. Again, it's retrospective, looking at cases from the past. As we mentioned before, sometimes case control studies are nice because you're not having to recruit people necessarily into your studies. You can pull existing case data and do that kind of retrospectively if you could get, say, hospital records or something like that that's de-identified for you to use. Other names for case studies are retrospective studies. Again, we said that we are looking back at something, whereas cohort studies sometimes are called prospective studies where we're looking into the future. Other names for this is case compare and case referent. So how have these studies been used? One of the more famous ones was a study done in the 1950s that linked lung cancer with smoking. As we were able to kind of make those correlations and inform the public of that, then that was kind of the beginning of those anti-smoking campaigns and us as healthcare providers really recognizing that there is a strong linkage. So started with patients that had lung cancer. We found a control group who were similar but did not have lung cancer, and then looked back into their history for exposure to smoking. Case control studies came first, and then we started following those up with cohort studies. So what would a cohort study look like for this situation? We would identify smokers and non-smokers who do not have lung cancer and then follow them for many years to see of those two groups who will develop lung cancer into the future. Advantages of this is with case-controlled studies, it does not take nearly as long as cohorted studies. Again, we're not tracking them for years and years into the future. It's typically less expensive than other research designs because, again, oftentimes we're involving medical records, as I said, rather than dealing with actual people. However, the caveat is that you can collect information through interviews with this. It doesn't necessarily have to be through chart review. This can be relatively easy to do. Sometimes the researchers don't need to go hunting down people for the data. Again, that your medical provider may provide you access to de-identified records for this. Different types of research calls for different designs. While experimental study treatments, case control studies investigate the causes of things. So experiments, again, we're looking at treatments. If I give you this treatment versus that treatment, what are the outcomes? Whereas in case control, we're really just looking at causation of what is happening here. So we're looking back to see what happened in the past and can we link certain exposures, possible causes with the disease. We can look at multiple exposures at the same time. However, it's not always clearly able to establish causation, but you can kind of establish a likelihood that that's probably the cause of it. It works well with diseases that are uncommon. And by starting with the disease, you ensure that you have enough cases to really kind of come to a conclusion. Disadvantages of using this is if the exposure is very rare, it can be hard to capture a statistically significant number. You would need a lot of different cases, and if it's rare, that might be hard to do. Again, these are not experimental, so you're not really proving causation. You are just increasing awareness of likelihood of causation, that there is kind of a correlation between these two. As one goes up, the other goes up. You have to be aware that you could be very susceptible to bias and that you are also susceptible to confounding variables. Again, those are those things that sneak in, unknown to us, but do affect our outcomes. Again, bias is an error in your design. A perfect study would not have bias, but again, even in the best of controlled settings, it's almost impossible to have a perfect study. Selection bias can happen in the cases and controls that we choose to look at. Are we matching people as closely as possible with age, gender, socioeconomics, health, geographical status? And why is this so important for us that our groups are as similar as possible? Other sorts of biases that we need to be aware of are information bias. People who have diseases are kind of likely to ruminate on these and remember long ago exposures, and this can be called kind of a recall bias, where they are bringing up things that maybe aren't really related to it, but as a way of trying to explain it. If there is nothing that is helping to blind our researchers, the cases might be questioned more intensely, or you may be spending more time with one medical record than another. So again, kind of that you need to make sure that you're delving into each case kind of with the same level and same amount of intensity. And then confounding, like we've talked about before, confounding is when there is an unmeasured variable that kind of links both exposure and outcome. If the controls are not matched appropriately, this can happen, and here's an example. If cases had a poorer diet than the controls, and we didn't somehow measure for that, that could be a pretty big co-founder when we're looking at health outcomes. Odds ratios, again, we have looked at this before. If you have a number that is greater than 1, you are basically indicating that you are at increased exposure for the disease, less than 1, decreased exposure. Again, that confidence interval that we've looked at, making sure that it does not cross 1. As soon as it crosses 1, that we are having something that is no longer statistically significant. The sophisticated use and understanding of case-controlled studies is the most outstanding methodological development of modern epidemiology. So, what is the point here? Many of you might think that you're just trying to get your bachelor's, and how is this going to be helping you in your nursing career? But we're hoping that it develops a greater kind of ability for you to critically think, which is kind of one of the tasks that we're really working on here as you are transitioning to your bachelor's degree, and that we are called on as nurses to do so much more than provide care these days, that we have a voice in determining how policy and practices are played out at the bedside. So I am not saying that you haven't been critical thinkers. Obviously you have. You've gotten to the point that you have in your careers. But push yourself in this class, that there's always room for growth for these skills in any of us. And it's an expectation that as you increase in your level of academic proficiency, that you will be able to understand and talk about these concepts in more and more depth. All right. So that's kind of our difference there in case-controlled studies versus cohorted studies that we talked about last week. And let's jump into Chapter 15 here on reliability and validity. Perfect. Okay, so Chapter 15 on reliability and validity. Again, reliability will, the same thing happen time after time. Is there consistency here? And then validity, this idea of, is this true? Are we measuring something that's accurate? And then there's another concept worth mentioning, and that's error variance. And that is the extent of variability in test scores. This is attributed to error rather than kind of true measurement. For an observed test score to actually consist of true scores, errors can be seen. These can be seen by chance or randomization, and it's really difficult to control for that. This can be due to accidents, mistakes, emotions that play into it, or you can have systematic errors that would also play into this, and these are like stable characteristics from the population that's being studied that might influence a response, or improper instrument calibration where your results are just consistently incorrect. So validity is concerned with systematic error, whereas reliability is concerned with those random errors. Systematic or constant errors, again, measurement of error that is attributed to relatively stable characteristics of the study sample that may bias their behavior and or cause incorrect instrument calibration. What does that mean in English? It just means that systematic errors are errors that happen in every measurement. They're not random. They've happened time after time after time because something was done incorrectly. Validity: does the instrument correctly measure the idea, the concept of interest? Measures can be reliable but not valid. A valid instrument, however, is reliable. So let's look at 3 types of validity here. Content validity: does the instrument measure the content that the researcher wants to measure? So are we accounting for the different things that we're trying to take a look at? Process validity: the researcher defines the concept and develops the instrument. Does this represent the concept? Can you use a instrument that contains items that really seek to measure the concept that we're looking for? You could use a panel of experts to help you assess those items. And you could use content validity indexing, which moves beyond a level of agreement within your panel of experts, and it actually calculates an index of kind of inter-rater reliability or agreement. And then there's base validity, which is just kind of a type of content validity, which means that the instrument gives the appearance of measuring the correct concept. There is also criterion-related validity. Does the subject performance that is measured by the instrument reflect his or her actual behavior in real life? As we know, as people are being measured, perhaps their true way of being can be skewed a little bit. So again, indicates to what degree the subject's performance on a measurement tool and the subject's actual behavior are related. There's 2 forms of this. There is concurrent and predictive. With concurrent, it is the degree of correlation between 2 measures of the same concept when they're administered at the same time. To be kind of valid when one is being tested. And then there's predictive, which is the degree of correlation between a measure of a concept and some future measurement of that same concept. So again, if I measure this now, if I measure this in the future, will there be kind of the same outcomes? So 3 types of validity. Again, we have construct validity, which is the extent that a test measures a theoretical construct, attribute, or a trait. The purpose of this kind of validity is to validate a theory that has underlying relationships. Constructs are these abstract kind of concepts. They're very tricky things to measure. So there are 4 ways that you could approach kind of construct validity. One would be hypothesis testing. You could do convergent and divergent approaches, contrast groups, and factor analytical approaches. With reliability, the extent to which an instrument yields the same results repeatedly, we are looking at things such as stability, homogeneity or internal consistency, and equivalence. So with stability, we are looking to see that the same results are obtained on repeated use of that instrument. With homogeneity, the idea is that the items in the instrument are all related to one another. They all are measures of the same type of a concept. And then within equivalence, that the consistency or agreement among the observers using that tool, that if multiple of us are testing something, that we're all agreeing that, yes, this is what this tool is saying to us, that we're using the tool in a similar manner. Reliability and stability. Tests of stability are looking at getting the same results time after time. So we have test, retest reliability. We have parallel or alternate form reliability. With test, retestability, again, the administrators of the instrument give it to the subject more than once. Scores are repeated from multiple tests. They're compared. And in this comparison, we are looking at a correlation coefficient, which is usually Pearson R. Again, this is a statistical kind of reference of, are these tests stable over time? And then parallel or alternate form reliability can be tested only if we have two comparable but not identical forms of instruments that are used. So again, the items on the test are similar, but they're worded differently. The same subjects are given two different types of instruments, and then we are looking to see, using both of these instruments, are we kind of getting the same outcomes? They should be highly correlated. Within reliability, we're looking for internal consistency, that homogeneity. Tests of internal consistency, all the items within a test are measuring the same concept. The instrument is unidimensional, and we are looking at one of four measures, kind of item to total correlation, split half reliability, this Cutter-Richardson coefficient, or Krochman-Alpha's Likert scale. Again, as we start talking about some of these statistical kind of concepts. Item to total correlations measure the relationship between each of the items in the total scale. Items that do not correlate highly with all of the other items might be deleted from this list. With split half reliability, we're involving dividing a scale into two halves and comparing those two halves. They should be correlated to one another. With the KR20 coefficient, it is an estimate of the homogeneity in the instrument. And then Krochman-Alpha's is the most commonly used test on internal consistency, and it compares each item in a Likert scale with others that are on that instrument. Reliability. The test of equivalence. Are two things equal? You can use this in two ways. One being just agreement amongst the observers that are using the instrument, and then agreements between alternate forms of instruments. You can measure this by inter-rater reliability or using kind of an alternate form similar to what we do with stability. Reliability coefficients are between 0 and 1. Research instruments, we're looking for those to be above a 0.7. Clinical instruments above a 0.9. Again, here are some of those different kind of testing that you can do on reliability. How validity and reliability are reported. They come in your methods section of your research report. The discussion is usually kind of brief and is just in a list format. It might give you the instruments that they're using. They might seek to define a concept or a construct that they were seeking to measure. And then they'll write a sentence or two about the reliability and validity data. So when you go to appraise the evidence of reliability and validity, you want to be asking yourself a couple of questions. What was the appropriate method that they used to test their reliability tools? Is the reliability of the tool adequate? Was an appropriate method used to test the validity of the instrument? Was the validity of the measuring tool adequate? And then again, all we're seeking to look for is, do they discuss strengths and weaknesses of the reliability and validity of their approach? They would do this in the discussions, limitations, or recommendations section of the report. So just how transparent are they being with that? All right, again, pretty high level stuff there. Use it as you see fit in helping you analyze the articles that you're doing here. And the last thing that we're going to look at here for this week is Chapter 16, which is, again, looking at kind of data analysis and those descriptive and inferential statistics. So put on your hats, go back with me a little bit here to your statistics class that you took a number of classes ago, and let's dive in here for a bit. So when we are looking at data analysis, we have our descriptive statistics. Those are kind of our easy ones. They describe and summarize what we were looking at. Those are those measures of central tendency, of mean, median, and mode, measures of variability such as range and standard deviation, and then maybe correlation techniques of scatter plots. Of if we look at all this data in one piece, what is it showing us? And then we have what are called inferential statistics, which are these where we are working to predict and generalize, analyze test hypotheses, answer research questions. We're using these to draw conclusions that extend beyond the data of the study. So again, as we are doing quantitative statistics, as we are doing those randomized clinical trials, anytime we are developing our PICO question, if we are going to be doing something that is very much of an experimental design, then we are going down this path of creating hypotheses, testing, and that sort of thing, which leads us to kind of inferential statistics. So levels of measurement helps us to look at the nature of variables or events and determine kind of our levels of measurement. There are 4 levels that we're looking at: nominal, ordinal, interval, and ratio. Within descriptive statistics, essentially all research, qualitative and quantitative, describe their sampling. So again, here we are seeing a frequency distribution, kind of bar graph to show us where our sample is spread over. Descriptive statistics, again, as we said, focuses on those measures of central tendency. So mode, which is your most frequent value in a distribution; median, which is the score in which 50% fall above and below that marking; and then mean, which is just an average of all those scores. So again, add them together, divide it by the total number of values, and we can use that with interval or ratio data. Again, within descriptive statistics, we have typically kind of a normal distribution curve, as you see, where the data set is symmetrically distributed, can be described as bell-shaped, where your mean, mode, and median all are similar. And knowing whether or not your data is normally distributed or skewed is kind of a fundamental thing for you to be analyzing. There's also, then, as I just said, non-symmetrical distribution, where it doesn't look like a bell curve. The peak can be off to the center, and you can either have a positive or negative skew. If you see data like this, then you need to have specific statistical methods to really be delving into this. So with descriptive statistics, again, we are measuring variability. Where is the spread of our data? How homogeneous or heterogeneous is our data? What is our range between our highest and our lowest score? And then what is our standard deviation? What's the average deviation between the center point, that mean, that we're looking at? So again, in a normal distribution curve, about 68% of the scores fall within that first standard deviation. 95% fall within 2 standard deviations, and then typically 99.7% of the data fall within the 3rd standard deviation. With inferential statistics, we are testing these hypotheses, as I said before. We are using data that's obtained from probability and non-probability samples. We are creating a parameter, what is a characteristic of our population, and then we are checking a statistic, which is a characteristic of the sampling. With inferential statistics, there are 2 hypotheses that we are testing. A research or scientific hypothesis, that is what you believe will be the outcome of your study. And then they have what is this null hypothesis, which is what you are hoping to, in theory, not see in your study. Again, the null hypothesis, as we talked about last week, is always restated as there is no difference between the 2 groups. We will not see this happening. There is always that negative connotation that it is the inverse of what we are hoping to see, so we will not see that happening. With probability, we are looking at what are the chances of obtaining the same result from a study that can be carried out many times under identical conditions. And the idea is that by repeating trials that we allow researchers to use probabilities to test their hypotheses. Within probability, there are types of errors that we might run into. Again, these are concepts that are kind of above what we are trying to look at here in this research class, but we will go over these for what they're worth. So we have type 1, where a researcher rejects the null hypothesis when it's actually true. The reality is that the intervention did not make a difference, but the researcher says that it does. A type 2 error occurs when the researcher accepts a null hypothesis that's actually false. So in reality, the intervention did make a difference, but the researcher says that it didn't. This can happen when a sample size is too small. With inferential statistics, the level of significance, the alpha level, is fairly important in that we're testing the probability of making these errors. So the minimum level of significance that's acceptable for most research is very small. So the p-value is 0.05. So again, there's a 5% chance that the researchers are wrong when the intervention, of saying this intervention will make a difference. So again, this goes to that 95% kind of confidence level. We're looking at statistical versus clinical significance. With statistical significance, hypothesis means that the finding was unlikely to have occurred by chance. But statistical significance does not necessarily mean that the intervention tested had really any sort of clinical relevance to it. So clinical changes might be important enough to support an intervention or a change in practice, even if we don't necessarily have the statistics to back them up. There's different types of tests for testing for difference. T-tests, ANOVA tests, and ANCOVA tests, perhaps were talked about in your statistics class. And then there are advanced statistical methods that you could look at too, such as multivariate statistics of multiple regressions and factor analysis, which are well above what we're looking at in this class. So again, when you're looking at the evidence of descriptive and inferential statistics, you're looking to see, were they seeking to describe the right kind of concepts here with their descriptive statistics? Was the sample size large enough to prevent extreme scores from affecting your data? Are the statistics appropriate to the problem? Were the research or the hypothesis presented clearly and appropriately, the hypothesis and the null hypothesis? Did you understand the results? And was a distinction made between whether this is clinically significant or just statistically significant? And how did they kind of make that distinction? Again, this kind of covers our material that we're looking at here for week 5. Week 6, we will start looking more at ethical concepts in using research subjects as test subjects. I hope that you really enjoy watching Maverick's Boys next week. Really fascinating film on the Tuskegee syphilis study that we conducted here in the United States and some of the ethical violations, unfortunately, that happened as a result of that study. So again, be preparing that next week your final paper is due for submission, and then for week 7 your presentations. So you're on the downhill stretch. Work on getting those lit review grids completed and turned in this week. Again, seek help from your professor if you're having a hard time deciphering any of the articles that you've pulled. All right, good luck.